So thanks for the invitation. I'm very happy to be invited. Thanks, Jonathan, Irene, Philippe, and so on for the preparation of my invitation and the travel to here. The topic of my presentation is using diversification of structure and species as a nature-based solution for forest stand management. And I was not completely sure. I just got this invitation, and you can talk about what you want, was the parola. But this morning I learned, I heard from Manuel the term structure, and from Hermina I heard these nature-based solutions, and from Gonfa these ecosystem services, and then I got a little bit more confident that I'm at the right place here. So I want to talk about these nature-based solutions, so how we can contribute in forestry to nature-based solutions. And I know that some, for example, Professor Del Rio, she does not like this, she told me she doesn't like this term nature-based solution, that is a political buzzword. And the foresters do that already since centuries, that they create nature-based solutions. But I think that is on the political agenda, and we have to show that some things, what we do, for example, when we want to create oak stands, Hermina told us that it is intelligent and smart to use the facilitation between different species with different traits to get the oak settled and to establish, and that is a nature-based solution. So here is a definition: actions inspired by nature to solve problems and provide ecosystem services. For example, if we would bring out artificial fertilizer or irrigate with a high carbon input, that would not be very nature-based or very smart. But for example, if we mix in an intelligent way, or if we cut gaps, or if we use the facilitation between nitrogen fixers and tree species, that can be nature-based. For example, what is not at all nature-based, that is when I come here for one day by plane to give this talk. But there are so many people here today, and I hope somehow that pays off, that I came for one day. So you all are familiar with these different ecosystem services. The regulating services, for example, the carbon protection or the erosion protection, the supporting services like biodiversity or water cleaning, the cultural services like recreation or human health and aesthetics, forest aesthetics, and here the provisional services, that is a traditional part, and they are simply a little bit in the background in the last 20 years, but they are still very, very important, these provisional ecosystem services. And I just show you some numbers here from the EU at the EU level. That is a standing stock in cubic meters of forest at the EU level. That is the annual growth. So you see that 2%, that is a good thumb value, that 2% per year is produced in forest in terms of timber. So in terms of biomass, 2%. And the annual demand is presently 0.6 billion, but the demand is increasing. So the prognostication is that it will increase until 2050 by 30 to 40%. So that means either we import from Brazil or from Russia, where they do huge clear cuts, or we try to increase the productivity here to integrate forestry and not to create too many national parks or set aside areas. So the idea can be to create more forests or to make the existing forests more productive. And the traditional approach, very, very simplified now, the traditional approach in managing forests was to establish plantations. So since 200 years, the forests do like this. And then they then to treat them in a way that they get more and more homogenized. So that means this is a diameter distribution of a stand, and if we would rotate this diameter distribution along the x-axis, then we get the height distribution of the stand. So that is more or less identical, as there is a strong close allometry between tree diameter and tree height. And that means this kind of management here, the thinning, this traditional thinning that cuts away these trees here in this dashed area, and that homogenize. So the stands become, at the beginning they are quite structured, but on the long they get more and more monolayered. And that is very widespread, this kind of management. And by this kind of management, by this homogenization, you cannot increase very much the growth. So these are very well known. I think you know this relationship. That is the density of the stand here. So that is fully stocked, and that is thinned here, more and more thinned. And then there can be a slight increase of growth, maybe 5–10%. But then if you thin more, it goes down and you lose productivity. So the productivity goes much below these 2%. So it goes to 1.5 or 1 or less. And it was analyzed, for example, for Norway spruce, and there is an increase, a slight increase if you thin, and it was analyzed for pine, and then you see there is hardly any benefit by this thinning. So there is not a lot to gain by the thinning. And in my presentation now, I will talk about other strategies of thinning, and that is thinning to increase the structure. So not to have all the trees in one layer, but to widen the structure, to make the diameter distribution, which, for example, can be quantified by the coefficient of variation of the tree diameters or by the Gini coefficient. So a low coefficient of variation, for example, would be 0.1, and a wide coefficient of variation of diameters would be 0.4, 0.5, 0.6, and at the same time it would widen the height distribution and the range in which the trees are distributed along the y-axis, so along the height of the stand. And that is the first part of my talk, and the second part is how to diversify, not in terms of structuring monospecific stands, but in terms of mixing. So how can this widening of the structure be achieved, not by structuring monospecific stands, but by adding tree species? And then the last part, so that will be about 15 slides here, and the last part, that will be 5 slides, that is the common principle behind the structuring and the mixing. So there is a common principle behind that, and I will address that and also derive some consequences for the management. So that is more empirical here. What is behind this structuring and mixing, and how can it be used for management of existing forest stands? So that are about 15 slides, and that are 5 slides, and then you have already done it. So very early already, there were some forest pioneers in 1885, 1920 in Central Europe, like Borgrewe or Möller or Reiniger, who had the ideas to treat forests not in the way I showed you before, that you homogenize, but they wanted to increase the structure. And normally the pioneers in forest practice are not very well recognized by science. So often they have some ideas and the scientists are skeptical. For example, these very, very well-known people like Wiedemann or Assmann, or they were skeptical with this structuring. But they had the idea to structure. So that means not to cut out the small trees to homogenize, but to cut out tall trees, not all tall trees, but some tall trees, to improve the structure. That means then the result is not this structure here, this homogeneous structure, but they come from the right side and cut away these trees, and then you widen the structure. So you can improve the space occupation and the heterogeneity of the stands. And Borggrave and Möller, they were the believers. Yeah? They thought that is like this, and Reiniger was the first who said, we trust in God, but the others need data, so we need data. And he started to establish trials to analyze this. And there was one very important scientist in Central Europe, Sterber, who measured for 50, now I had a contact with him as I did not know exactly one date, and he told me, no, we measure since 50 years, we measure these stands. And then they look like this, so they started here 40 years ago, and there you see the size distribution here, and they tried to widen the size distribution. That is a diameter here, and they started with a Gaussian diameter distribution, so very homogeneous. And then they cut it away, tall trees, they called it structural cutting, threshold diameter cutting, cutting from above or something like this. And then you see over a very, very long time, they were able to extend the diameter distribution of the existing stand, but there were also, of course, some new trees coming on. And that means here that is an increased structuring. And then they analyzed the productivity, and they found that in the face of the structuring, of course, there is some natural regeneration coming, but if you don't count that, if you simply look for the existing stand, then it was possible to arrive at an over-yielding of 10 to 20%. So 10 to 20% more than expected simply by creating structure. And in the past, we used this term, or this term was often used for mixed stands, this over-yielding, to say how much more is the productivity in mixed stands compared to pure stands. But now we use it for quantifying the productivity of heterogeneous monospecific stands compared to homogeneous stands. And there was a plus of about 10 to 20%. That is interesting. That does not need energy input so much, no fertilization, just lectures or knowledge. That is an own study where I did something similar with a different approach. I analyzed stands, again, monospecific stands. So stands with, in this case, of Norway spruce, but in running projects, we also do that with other species. And where you create diversity, structural diversity, not by cutting away tall trees, but by mixing different genotypes. For example, different provenances or different clones. We scanned that here, and you see they have different shapes. And you can quantify the different shapes by the allometry. Yeah, by the allometry that was scanned here, and then we analyzed the scans like Manuel showed in the morning, and then you see the different allometric coefficients, and then it is the same effect. So you mix different provenances, different genotypes, and you get a plus of 10 to 20% compared to homogeneous stands. And in order to get, so what you see here is simply the plot where all the trees are standing here and that are different genotypes. So the genetics were analyzed, and so we know the different traits, the different provenances, and they have different neighbors, and then they arrive at a higher packing density. So some are made for living in the dominant layer, other are made for living in the middle, and other made for having long crowns and are more drought, more shade tolerant. And in order to understand that a little bit better, we did an analysis in a huge project now in the last 3 years where we combined 34 long-term experiments, so that across Europe, with a number of 125 plots and surveys, 610 surveys, and they reached back very long. So the first analyses were made 150 years ago. I mean, the first surveys were made 150 years ago. So this value of long-term experiments was harnessed. And then we found, and that is the main result, very simplified. Here is the productivity on this axis, so the growth, here on this y-axis, and here you see the effect of the stand density and the effect of the structure. And the key results were, over all these plots, that of course if you have the maximum stand density, you have a high growth, and this growth is reduced if you reduce density. But there is also an important structural effect. So a low structure causes a low growth, and if you have a higher or medium structure, you increase growth by 15 to 20% simply by structuring, and we are talking about monospecific stands. By structuring, and then that is not completely clear whether it goes down again or it keeps, it may differ depending on the species. So it behaves if the structure is getting very, very high. But the key message is that even in monospecific stands, the structuring effect can be very important, and structuring in this context means widening the size distribution, widening the height distribution, increasing the space occupancy, and this was analyzed for Norway spruce here. And maybe in case of the other species like pine or oak or beech, that may be different, this pattern, but in case of Norway spruce, it is like this. And maybe we started to analyze the same for the other species, and there seems a little bit different shape, but the structuring was always helpful. But of course, especially with pine and with beech, the degree of structuring, as they are very light demanding, is limited. So maybe it is important in this case to add other players, so to mix, for example, to add beech to the pine or to add beech to the oak and so on. But that is a topic of the next section. I first summarize the first part. Structural heterogeneity can raise stand growth by 15 to 25% compared to homogeneous stands. In the case of Norway spruce, it's important. It seems to be a little bit similar for example, in fir stands and in beech stands, but second, it can be created by thinning from above genetical diversity, age differences. So that means all measures that somehow mix different traits in a stand can increase the space occupation. Ensembles of small and tall trees improves resource use, stand density, and growth. But the gains are limited by the species traits. But the important thing I learned that an ensemble of trees, I mean a special mix of small, medium-sized, and tall ones, can have a higher benefit than these traditional approaches of making all trees the same size and making them dominant. So if you don't thin, that is the Darwinian procedure, that some dominate the society, in this case the stand. But if you thin a little bit and you reduce the dominators, then you get an ensemble of trees with different sizes, and that seems to be that in this case structure causes diversity, and diversity causes an increase of productivity. So I get to the second part of the talk, and that is now the effect of mixing. So far I started with this homogeneous stands, traditional approach, structuring by for example, thinning from above, by threshold diameter thinning, by structural thinning. And of course that is limited here, what I can achieve in structure, especially in stands that are always species which are very light demanding. Then the potential of structuring may be limited, but it's not so limited if you add a new species. For example, if you have one species here that is shade tolerant, and you add another species that is light demanding, and then you establish them in a smart way in the space. So that is again, if we rotate this diameter distribution around 90 degrees, then we get the height distribution more or less, and that is shown here, the effect. So if you mix these monospecific stands with a second species, then you see here, it's just a visualization, but then you see here that the canopy space is more occupied, and that is simply the result of increase of the size variation. For in very extreme situations here, you have the pine stand, the monospecific pine stand, and if you add beech, for example, and these stands are very common in over half Europe, then you see that the pine is in the overstory, the beech is in the middle or in the understory, and then you have beyond the structuring of a monospecific stand even more structure by mixing. And something like this was analyzed when Andres Bravo is sitting here in this lecture room, and he initiated this Oymix4 project. And there in this Oymix4 project, there was the idea we can analyze that. So we establish triplets, one monospecific stands of beech, one of pine, and then we mix it. And we establish stands like this across half Europe. So a lot of people contributed to that. You see here the different triangles, but they are often, when there is one triangle, that were several plots. And then the result was, to make it short, the volume productivity in the mixed stands was 15% more than in the monospecific stand. So you have the monospecific, the other monospecific, and if you compare the mixed product, the productivity of the mixture with the monospecific stand, then there was a plus of 15%. The density was higher, so 20% higher density in the mixed stand, and the structural diversity was higher. That was a plus of 29% in case of this mixture of pine, and beech. Of course, that are two species which have different traits. The beech is very shade tolerant, the pine is light demanding, and but that was interesting that we started with this intuitively somehow. We started with this mixture as we expected something from this mixture, and that was an interesting start. And one possibility, I will get later back to this kind of graph, so it is good if you listen now, that are so-called cross diagrams. So cross diagrams, and here is the productivity of one species, in this case is eucalypt, and here is the productivity of the other species, in this case it's acacia. Monospecific. And if the mixed stand would be the same as the monospecific stand, the productivity would lie on this broken line. So that would be simply a weighted average. And here in this case, there was a plus of 60%. So the mixed stand produced 60%. So just to tell, I mean, if you would get an increase of the salary of 60%, you would be happy. And in case of the productivity of forests, it is creates happiness for the forest owner, as it's without fertilizing, but it's a little bit the same effect as Hermina showed this morning, as you have a mixture of one species which is not able to to fix nitrogen, and another species which is able to fix nitrogen. And in this case, these cross diagrams not only show the benefit in total of the mixture, but they also show that the main increase is coming from the eucalypt, which is fertilized by the acacia. The acacia in this case is a nitrogen fixer, and the eucalypt benefits. And the other way around, the acacia also benefits a little bit, probably by light use. But what I wanted to show you is that these cross diagrams, they are often used for visualization, and we get back to such cross diagrams a little bit later. But this plus 60% is extreme. We did not find that in our forests in Central Europe, and that is extreme, and that is also a special case, as there is not somehow a more efficient distribution of the existing resources between the small and tall trees, but here are additional resources coming in. So there is nitrogen fixing, and that drives the productivity up to 60%. I mean, in our cases, we mostly have maximum of 25 or 30% of plus. But here in this, so that is a special case, this mixture of acacia and eucalypt, and I showed it more to show a special case and also to show these cross diagrams. And now there were a lot of studies, and I just showed 2 studies that analyzed in principle these, or that try to bring these empirical findings of selected mixtures into a context. For example, Hervé Jactel in Bordeaux, he analyzed, he used 126 studies, 60 sites, 5 continents, and that was in this time, so 10 years ago, these meta-analyses were the hype, so solve the things by meta-analysis, and he put all this together, and then he found productivity that is 100%. That would mean there is no effect, so pure stands produce the same as monospecific stands, and here everything, all points above the 100% line is over-yielding. That means an increase of productivity above the monospecific stands. And there are some extreme increases, and the mixture of deciduous trees and evergreen trees is more positive than the mixture of evergreen and evergreen species. But in essence, he found on average a plus of 15% over all these studies. So there were no own studies, that was just a kind of compilation of existing studies, including the studies Andres Bravo did, this pine beech study. And that was based on long-term experimental plots. So very, very important work here, as experimental plots, they provide very, very good data. I mean, they measure very precisely over long time periods. And the other extreme here, that is Liang, what he did, that he analyzed for 45 countries worldwide, very many sample plots, so more than 700,000 sample plots. So that is the other extreme, not very precise measurement, small plots, but a huge number of plots worldwide. And he found it's the same. He used the species number and the productivity. And one thing, on average, there was a plus of 25%. But what was more interesting, he had, especially by the stands of the subtropics and tropics, there were stands with 150 tree species or so, and he found an asymptotic development. So if you have one species and you add a second species, the marginal benefit is very high, so can be very high if they are complementary regarding their traits. If you have a third species, the empty niches are already a little bit reduced, and so that is an asymptotic curve. So it is not so surprising. It's the same if you fertilize, so the first, or if you drink a beer, the first is the best, and the second is already decreasing a little bit, and then it becomes more and more asymptotic. Yeah. So that were studies, and they provide a general knowledge which is not so easy for I mean, it's important that you can say there is something with mixing and there can be achieved something, but for the forest practitioner, or if you want to create silvicultural guidelines, it's not so easy to use this, as there is hundreds of species, or here many different species. And so we started, and that are now results from a current study where we use the main mixtures in Central Europe. And we say, okay, we know now that in principle there can be a benefit, but now we analyze oak beech, spruce beech, oak pine, pine beech, pine spruce, these 5 mixtures, based on long-term experiments, a huge number of plots again, and across Europe. So there is a lot of data behind that. And then the first slide here, I just show 2 slides regarding this study. And the first slide is, here is always monospecific and mixed, and you see that the density, that is a stand density index, it's not so important, the theory behind this, but mixed stands are simply 25% denser, or can be 25% denser than monospecific stands. And here's a structure, and that is what I meant at the beginning, for example, the coefficient of variation or the Gini coefficient. Are they narrow? So all trees concentrated around a diameter of 25 centimeters or so? Or are they wide, that the tallest tree is 1 meter, and the smallest is 20 centimeters or so? And then you see, on average, the mixed stands have a wider structuring. So the coefficient of variation of the diameter is 26% higher on average over all the plots. And the volume productivity, so the annual growth in terms of cubic meter per hectare and year, it's still an important, not only as it is my favorite, this productivity, but it's important as forests are still providers of timber, of fuel wood, and so on. And here you see a plus of 19% on average over all these different mixtures. And the over-yielding, so that is the same result, the over-yielding is 19%. But it's interesting that the dimension of these, for example, these 19% or so, that is not so different from the dimension which I mentioned at the beginning as the effect of the structuring, when we simply structure monospecific stands. And now we wanted to here are coming back these cross diagrams. That was the reason why I showed this slide by Forrester about the acacia and eucalypt plots. And here you see now the 5 mixtures, 1, 2, 5 mixtures, and here are the most productive mixtures, and that is a plus of 25%. And here are the most lowest over-yieldings, that is a plus of 6%. That is a mixture of oak and beech, and that is a mixture of pine and Norway spruce here. And in essence, you see here how they react and how that is the over-yielding in total, and that is the over-yielding here of the 2 species. So which species is contributing to the over-yielding and which trees is losing or winning. But the most important message for me was, and that is a still ongoing study, that was that this mixture, for example, spruce and pine, that is most productive. And here you see that it is a mixture with different traits. So the pine is very, very light demanding and transparent. So that is also the reason why I asked Manuel for this transparency. That is important for silviculture. So the pine is transparent, and in this case the spruce is more or less below these pines, and the spruce is shade tolerant, and this here means they have different traits, so there is a difference in traits, a strong difference in traits, and the arrangement in the space is smart. As in the upper layer, there are the pines, and a little bit lower are the spruces. And here you see a similar mixture which is very different in traits. So the beech that is a beech here, this green, this dark green. The beech is shade tolerant, and the oak is light demanding. And here you see it's also a strong complementarity in traits, but the spatial arrangement is a little bit stupid. So as normally the oak should be above the beech, then you would exploit these these trait complementarities. So and here, for example, you see that pine and beech, that is a mixture I mentioned before, is somehow in the middle in the overyielding. So the main message was that two components are very important, and that is the trait difference, I mean the trait complementarity, and the arrangement in the space. So it is not sufficient to say, okay, they have different traits if they are not allocated in the space in the way that they can exploit their specific traits. For example, if the oak is below the beech and suffers by the shading of the beech, so it cannot exploit this overyielding. So the summary of the second part: mixing can raise space filling, density grows by up to 25% compared to monocultures. Beneficial are complementarity and respective spatial arrangement. So these two, for example, I symbolize that here. So if you have something like this, that you have these light demanding species on top and the space, the shade tolerant species below, then that can achieve the highest potential of overyielding. And here generalizing requires empirical studies with different trait combinations, and that is one of the ideas of Professor Philippe Bravo, that we said, okay, that is nice, we have now these 5-6 species combinations in Europe, but in order to understand that, we need a wide range. For example, these worldwide triplet approaches you are working on, that are 10 or 20, 30 different trait differences, but also we have the mean diameter, so we know whether there are complementary traits in this stance, but also if the mean diameter of the species with one trait is lower or higher, so that is also an indication of the spatial arrangement within the stand. And now the last part, only 5 slides coming now, and that is the common principle and consequences for design and management. So that was more the background information. So what is behind the structuring and mixing, and what are common principles behind that, and what are the consequences for design and management. I mean that there are many consequences, and it is I think presently there are 20, 30 research projects funded by the EU dealing with mixtures, and that is also only a trial to nail down a little bit what are the consequences, what are the consequences of what I've shown so far. And one common principle for me, how I understand that, and some partners too, that is here the visualization of what is going in monospecific stands. So for example, if they are completely layered, if they are monolayered, then a lot of light is reflected and not used for the stands. So it's simply going back. And that is blocked here. That is what I mentioned, that is a Darwinian approach, that you let the forces of nature just develop. So then the stands do not want to maximize their growth. That is not a natural idea. The natural idea is to maximize fitness. But if we want to maximize productivity, and we cut away some of some of the tall trees, I don't mean high grading in US where they always or in Canada where they always cut the best trees. It's not what I mean. What I mean is to open a little bit. And if you open a little bit, then the light can penetrate deeper into the stand. And if you open a little bit more, the reflection is less and the penetration is going deeper. And it's the same in agricultural stands. So in modern agricultural textbooks, I found the same ideas. But that is a topic of the round table afterwards, these block between agriculture and forestry. But here you see the same thing in the mixed stands. But in the mixed stands, it is somehow that the penetration of light and the feeding of the small trees is not made by cutting away some of the tall trees, but by replacing the tall trees by other tall trees which are more light transparent. So that means mixing is somehow the same as thinning, a little bit like this. So it has the same effect. That if you, for example, mix here some larches in or some pines, then you feed the understory, and the advantage in mixing is that you don't cut away. So it's not so important to cut trees, but to replace trees with other traits, but in the right layer. And so, for me, it becomes very obvious that a key role in both systems plays the stand structure. So that the stand structure is mainly affecting the growth, and that you create a stand structure, a clever and smart nature-based solution, stand structure, by trait combination and by spatial arrangement. So one thing is not sufficient. So it means if you have interesting trait combination and you do a wrong spatial arrangement, you reduce the structure. But if you combine both in an intelligent way. Now I'm talking about the vertical structuring. Maybe later in agriculture we can also talk about the structuring in terms of horizontal structuring, the mosaic over the landscape. But the main result is the structure made by the trait combination and the spatial arrangement is the main effect that causes this over-yielding in mono and mixed stands. And that these bold arrows here are very important. And these small arrows, these thin arrows here, for example, like nitrogen fixation or soil improvement, that also plays a role, but that it plays a minor role. So 10, 15 years ago, we thought that is if you mix two species, then the leaf and the processes going on in the soil, that are the most important things. But now several groups came to the conclusion that that is important on the long, and there can also be, for example, exception nitrogen fixing, eucalypt, acacia, that can also play a role. But the main in our Central European stands is the trait combination and the spatial arrangement in the structure, and that can be, I now address the structure above ground, but in drier stands that can also be the spatial arrangement in the below ground. So that is the same, it's just that I addressed now the above ground structuring. So that means if I get back to this traditional approach, that a part of the over-yielding, especially in shade-tolerant species, which you can structure, then it is possible to arrive at an over-yielding by, for example, genetical diversification, structural diversification by mixing different provenances or different clones. We visited clone trials in South Africa where they tried to a lot of areas in South Africa are covered by eucalypt or Pinus radiata or so, and they, of course, they make a lot of money with this, and they do a lot of erosion or produce a lot of erosion and water problems with this. And now they do not want to shift to complete natural stands like in Europe, as they don't have these other, they don't rate these ecosystem services so high as we do, as we are so densely populated, I mean, in Europe. But they start now to mix clones, and that is also interesting that they really even engineer clones, that they have some clones of eucalypt which are occupying the upper part and also the deeper part in the soil, and others which reach not so high above ground and not so low below ground. And that means that is a structural difference that can cause a structural differentiation, or an allometric, I mean allometry in terms of what is a relationship between diameter and crown. Some have a diameter of 20 centimeters and a crown with a width of 5 meters, and others with 6 meters or so. So that can also be interesting to combine different allometries or different ages. We know that oak, for example, is shade tolerant when it is small, and it is more light demanding when it gets older, and so it's also possible to use a monospecific setup, but differentiate the age, and then you also cause different traits. Also, it's the same species. But of course, this approach here is limited, especially in case of light demanding species. And I showed that these over-yielding of mixed stands, if that are combinations which are intelligent mixtures, you can achieve a lot of, and that are always average values. So when I showed you these hundreds of plots, there are also some where you have an over-yielding of 100% or 120%. So that are average values, as these exceptions are not so interesting. Important for forestry is to know, or for a forest owner, it's important to know what can I achieve on average. So is that reliable, what they are doing there in Palencia or in Munich or so, these group of forest scientists. And here on the right side, I tried to sketch very simply what should be avoided. So that is a positive, what you can achieve when you act positively, but when you act negatively, then it's disadvantages if you have all the trees packed in one layer, or if you combine two shade-tolerant species in one layer, or two light-demanding species in one layer, which are very similar, so that then you cannot expect a lot of benefit. And very negative is if you have in the upper canopy the shade-tolerant tree species. Shade tolerance means mostly, nearly always, that the crowns have low transparency. I plotted, for example, of many species, the shade tolerance, according to Ninemets, for example, then you have the shade tolerance of 150 or 200 species, and the light transparency of the crown, and then it's always like this, that the higher the shade tolerance, that is very nice, but the disadvantage is always, if there is a high shade tolerance, the crown is very intransparent. So I mean, if you combine this here, that you have in the upper part, for example, the beech, and in the lower part, the birch, that does not work on the long, so that there is no benefit. Now the last to this chapter 3, and I want to bring again these mono and mixed species stands together into one general concept. And I tried in the first part of my talk, I tried to show you that the stand density can increase. The productivity, here's always the productivity, the stand grows. And that also the structure can increase. That is for monospecific stand, and that is for mixed stand. And if we put that together, then we see that the main benefit from the mixture comes from the fact that the mixtures are more structured, and so the productivity is a bit higher. And the maximum stand density can become higher in mixed stands. So this here, this layer, which is hardly visible, and this is a mixed layer, and then you see the main effect on stand growth is that the mixing arrives at higher stand densities, that is on this axis here, so it goes further 20% more, 20% denser compared to monospecific stands, and the structure is higher, and the higher density is behind. That is a interaction between structure and density, and I mean the density is higher as they are more structured, and this is very important. Why is this important? Why is this important? This is important as in presently the silvicultural prescriptions, so how you cut the trees in practice, are often used from the monospecific stands. So the density set points or the guidelines are designed for monospecific stands. And if you would apply them for mixed stands, you would, I call that the thinning away of the mixing effects. So you reduce the density and you reduce the structure, and the consequence here, it is, for example, mixed stands which is kept a little bit denser, and here that is a mixed stand which is managed like a monospecific stand. That means if you follow guidelines which have been scheduled for monospecific stands, and that is done all over Europe, as there are hardly guidelines for mixed stands. Very few. We tried to made a questionnaire for more than 15 countries and found hardly in Spain there are some guidelines for mixed stands, but qualitatively, not quantitatively. But that is a very important consequence. If you simply follow concepts like select 100 trees and cut away 3 neighbors of every crop tree, and if you would apply that for mixed stand, then you thin away the mixing effect. So mixed stands can be kept denser, and they should be kept more structured. That does not mean unmanaged, but if you manage them similar to monospecific stands, then in many cases you thin away the mixing effect. So that is the last summary. Increase of resource use by ensemble of trees with size variation as common principle. So that means in monospecific stands when you structure them, or in mixed stands when we add additional players, so additional species, then in the principle behind that, behind both approaches, is that you keep an ensemble of trees of different sizes that can use the resources better than a very homogeneous stand. Structuring by complementary traits and special arrangement, that is very important. That traits alone doesn't make it, so it's important to design it in a way that you exploit the potential of the complementary traits. Considering the increase in density in models, guidelines, and thinning prescriptions, that is important, otherwise you lose the benefit of mixtures. In my talk, I mainly addressed so far this productivity effect, the growth, as that is my favorite was my favorite topic the last 5 years or so. And I want to add just two that you don't go out here and say it's this guy who only thinks about productivity and cubic meters or so. It is clear that mixing or structuring also can improve the biodiversity. Many studies, I just showed 2 here, selected 2, that if you have a structuring or a mixing here along this axis, you increase the biodiversity. So that means that is an increase of the regulating function. If you have a mixing, you can reduce the stability in terms of stability against snowfall and wind damage. So very well known by Knoke, Brandl, Powell. Many studies show that here is a probability of survival, and here is a stand age, and then you see mixed stands have such survival curves, and monospecific stands, they have a higher probability to be blown down. the drought resilience. Many, for example, Mataparos, Mira del Rio, they published a lot of studies that if you have a drought year and you look for the reaction regarding the growth in mixed and monospecific stands, that in many cases, not in all cases, but the mixed stands often are reduced less in growth compared to the monospecific stands, not always. And here just the carbon sequestration also can be, but that is clear if the stand density is higher and the growth, that is just a multiplication of the cubic meters into carbon. And there can be added many more. I want to get back to the first slide of my presentation, when with these regulating services, the supporting cultural services, and the provisional services that are the four pillars for ecosystem management. And then you see that this structuring and mixing is really a nature-based solution that is able to increase the provisioning services, so the cubic meters, but at the same time it can increase the cultural service, like the aesthetics or the beauty of the forest, or the supporting services, for example, the biodiversity or the filtering. As if you have more canopy space, there is more filtering of the air or of the carbon fixation. So that means, in essence, these measures I tried to address, these structuring and mixing, are in the best sense nature-based solutions, and forest managers can use them, and that is my last point, can use them to integrate forest ecosystem services into existing stands without saying, okay, I set aside the whole area or make a natural reserve or a national park. Maybe that is also impossible in cases, but it's not necessary. We can increase this 2% of productivity to 2.5 or so in Europe by increasing the forest area and improving the productivity on the area without setting aside everything and importing the wood from Brazil or from China or so. So that is also, the nature-based solutions are also a possibility for integrated forest management, for integration of ecosystem function, and that is maybe a topic later for this round table talk. And now I come to the last slide, and that is a very important slide, and that I want to thank the Bavarian State Ministry for Food, Agriculture, Forestry and Tourism, as they are still funding, since 150 years they are financing the survey of our long-term experiments. And there were times where they said that is all nonsense, why do we need that? And then there came the acid rain, and then they were happy that we had that. And then they say, give them up, we can save a lot of money, and then there came the carbon period. And they were happy that we had that. And then they say, give them up, we can save a lot of money. That were always new ministers or minister secretaries, and we always convinced them, please don't destroy our network. And then they came this period of biodiversity and of carbon and of climate change. So that means over 150 years, they kept that and they financed that. And that are some thousand plots. And I know that you also have plots like this here in Spain, and it is important to keep them. Then you can contribute to such studies, and if there are international studies, you can contribute and become a member of these groups. I want to thank the EU, very important. For example, the Oymix Forest was the first project which really addressed very, very deeply this mixing. There's also a book was resulting from this. Andres compiled this book here coming out of the Oymix Forest, this reform, care for sea, ETN skill for action. So a lot of funding for this, and behind these slides. And many, many partners in several countries provided the data, and we still always, if we do some evaluation like I showed, we always ask everybody, are you wanting to contribute? They're very important networks, and several of them were created in Spain. I mean, this Oimics for reform they were simply created here in Madrid or in Valencia. And the last for me, very important, that I like very much that I was invited so often by Felipe Bravo and Miren de Rio to Spain to work here. So when I was in Munich, a lot of you all know, or most of you know, that administrative issues, conference to organize like this, speakers who do not end to talk, yeah, Jonathan, it's terrible. And then you come to Palencia and sit in an office with Cristobal, who is really hard working and programming, and that inspires to work scientifically. And I'm very happy, and thanks you very much for this hosting and you for the listening today. Thanks.